Assalamualaikum and a very good day to my panels and other viewers. In this video, I will present my FYP1 proposal, which is Finite Element Analysis FEA of the Mini Hydro System. First of all, my name is Afiq Nasrat and my supervisor is IRTS Dr. Muhammad Azim Majusuf. In this slide, it shows the general fact about the hydropower. It is one of the first sources of mechanical power and the oldest renewable energy in the world. 2000 years ago, hydropower was already used in China along with the invention of water wheel in ancient Rome and Greece. From that event, various applications of water wheel expand unusually during the Middle Ages and important for power generation in Europe and other regions. This technology keeps on evolving until the current time and widely used in 2016, and a total of 159 countries in the world have developed hydropower. Hydropower has numerous types of sizes which are categorized as large and small hydropower plants. The small hydropower plant consists of 4 types which are small, mini, micro, and pico, and the table below shows the power consumption for each type of the plant. Pico-hydro is mostly applied in rural areas due to its lower power consumption. As for this research, pico-hydro will be focused as it is more suitable for smaller consumers and has lower power consumption. This slide shows the problem statement of the current study. The application of the turbulence model into the numerical scheme can produce a huge difference to the simulation results. However, different models produce different simulation results. This is due to the boundary conditions that has been set and also depends on the complexity of the model. It is important to choose a suitable turbulence model which can help achieve the convergence results. With the results, the simulation data obtained will be relevant and also reliable. In this slide, the objectives of this research are: first, to perform CFD simulation of the pico-hydro and previous mini-hydro design. Second, to compare the simulation result between the pico-hydro turbine and the previous mini-hydro turbine. Third, to observe the effect of the nozzle applied on the system. This study will focus on performing the CFD simulation of the pico-hydro turbine. A turbulence model is used to determine the convergence result. However, the research can only monitor the performance of convergence at limited level only due to limitation use of CFD software. For literature review, first is the Finite Element Analysis FEA software. FEA is a program used to solve various complex issues in any scientific and engineering fields. Various types of models, such as structures, machine components, or nozzles, can be analyzed using the FEA method. FEA can analyze the behavior of the models in terms of strength, fluid flow, elasticity, and other elements. During the FEA, the boundary conditions are determined, and it is reduced to the understanding of the restriction comment on the model without worrying about its mathematical form. It is important to consider the selection of the number and type of finite elements because it has a high impact on the time needed to obtain the accuracy and results. It is also necessary to select the appropriate shape of the finite element, which include the number of nodes on each of its edges. Nodes and elements prove to be important in finite element analysis. As for this research, ANSYS software is used for FEA. Next is the turbulence modeling. As you can see, this table shows the comparison between turbulence methods or models. The main purpose of turbulence modeling is to assist equations to predict the temperature fields, time average velocity, and pressure. With this modeling, there is no need to calculate the complete turbulent flow pattern as a function of time as in large eddy simulation equation and Reynolds average Navier-Stokes equations. As for this research, the Spalat-Almaraz model is used as the turbulence model. For this slide, it shows the CFD convergence using residual. As you can see, this figure shows the example of the residual monitors. It is the main tool for judging the convergence because it can monitor the solution of the basic equations for the CFD simulation. The simulation includes equations like pressure, turbulence, and momentum. After that, the solver will conduct iterative solutions for these equations. As a result, the difference between the solutions of these equations can be seen throughout the residuals plot. There are various root mean square or RMS residual levels, which are 10 to the power of -6, which is tightly converged, and 10 to the power of -5, which is well converged, and 10 to the power of -4 and -3 are loosely converged. As for this research, the RMS residual levels of 10 to the power of -3 is used due to the limitation of the software. This slide shows the methodology used in solving the problem of the current study. CATIA V5R20 is used to design and construct the finite element model, which can be seen in both of these figures. Then, using the ANSYS Fluent, the model is then simulated. As for the turbulence model, the Spalart-Almaraz is used. The volume flow rate of 0.5 times 10 to the power of -3 meter cube per second is used as the boundary condition at the inlet of the pipeline, with the density of water is 997 kg per meter cube. Using the residual level of 10 to the power of -3, the residual values obtained are converged and the simulation result can be obtained. This slide shows the flowchart of the current study. As you can see, at the modeling stage, the finite element model is designed using the CATIA V5R20 software. Moving on to the next stage, the simulation involves in using the CFD software, which is ANSYS. After that, simulation is done on two designs, which are pico-hydro and mini-hydro design. After finishing the simulation work, the convergence is checked. Then the simulation result is obtained and then summarize the data. As for this slide, it shows the preliminary result, which is the velocity magnitude contour. Based on these two figures, there are two models, which are Model A, which is with nozzle, and Model B, which is without nozzle. It can be seen that the average velocity for Model A is higher compared to Model B. This is due to the existence of the nozzle that has been applied in Model A. Next is the pressure contour. Based on these two figures, we can see that the average pressure for Model A is higher compared to Model B. This is also due to the existence of the nozzle that has been applied in Model A. Next, we discuss the simulation result. First is the average velocity and pressure of the base model. Based on this table and both figures from previous slide, Model A shows higher velocity and pressure at the nozzle output. However, Model B has a lower velocity and pressure when there is no nozzle applied on this model. To ensure the efficiency of the blade, the position of the blade is best to be put around this area. As a result, the Model A proved to satisfy the purpose of the nozzle as it produces a high water velocity at the nozzle outlet than at the inlet. Next is the volume flow rate at pipeline outlet. As you can see, the table shows the result of volume flow rate at the pipeline outlet. From this table, we can see a negative value of the volume flow rate. This does not affect the simulation result, as the negative value is due to the outward flow of the fluid. Compare with the actual flow rate, which is 0.5 times 10 to the power of -3 meter cube per second. Model A obtained a total of 0.02% difference between them, while for Model B, a total of 0.01% difference is obtained. As a result, Model B produces a better efficiency of fluid flow as it obtains lower flow rate losses. For this slide, it shows the convergence result of Model A and Model B. Based on these two graphs, Model A takes around 22 seconds to reach convergence at an iteration of 58, while for Model B takes around 90 seconds to reach convergence at an iteration of 46. Both of the models use residual values of 10 to the power of -3. As a result, Model A reached slower convergence compared to Model B due to Model A complexity, and additional work is needed to simulate it. To conclude, as a result, the study has managed to perform FEA simulation on the pico-hydro and compare between two models, which are Model A, which is with nozzle, and Model B, which is without a nozzle. Based on the simulation result, the average velocity and pressure value at the turbine section have been obtained. During the next session, the result shall be used to estimate the power produced by the turbine. A comparison will be made between these two types of data. For the next stage, the focus will be on the theoretical calculation to extract and compare the simulation and experimental results. For this last slide, it shows the Gantt chart for the planning of FYP1 and for upcoming FYP2. In FYP1, there are 6 project activities has been done throughout the study. Based on this Gantt chart, from these 6 activities, the timeline for each of them has been successfully followed during the FYP1. As for FYP2, there are 5 activities that has been planned. That's all from me. Thank you for watching and Assalamualaikum.